Hey my colleagues, this is Softwaring and I'm Lorduman, and in today's video I will bring you very important concept on Ansys Workbench. So in today's video I will show you some problems related to static analysis. So as you know from the previous videos, Ansys software has two main branches. The first one is the PDL and the second one is the Workbench. So in this video I mainly focused on the Workbench analysis. So as you see from the problem, the dimensional information used to create a cantilever beam is given below, and also it is subject to a transversal load of 100 Newton at the free end, and it's fixed on the other end. So we have to analyze the beam, and we have to extract the total deformation and the directional deformation in X, Y, and Z axes, and we have to use the structural steel as a material of the beam, and in this particular example and all the dimensions are in millimeter. So in this video I will show you how to do this step by step. Keep watching. So once you open your Ansys Workbench, it displays like this. So since we are doing structural analysis, we have to double click or drag this structural analysis to the standard system. Once this opens like this, so we have to adjust our engineering data. So from the engineering data there are many materials I will show you in the coming videos. For the current now, we command to use structural steel. So we select structural steel. So this is the material used in the structural steels. So after the engineering data we have to get in the geometry stage. So in this design modular we have to fix our unit. So our the dimensions are millimeters, so we have to select our units, our millimeter as a unit. So after doing that we have to select randomly one plane. So let us select the XY plane and let us make it normal to the plane, so we can start our sketching. So let us create our beam by using rectangle. So I create this rectangle, then I have to dimension it. So the beam length and the beam width, the beam length is 250 millimeter and the beam width height is 10 millimeter. Let us generate, and after doing that we have to extrude 50 millimeters. So the depth is 50 millimeter. So let us make this 50 millimeter. Yeah, we just create a three-dimensional beam. So if you make it an isometric, we could get this rectangular cross-section beam. Once we create this geometry, we have to close this design modular, and then we have to proceed to the model stage. So in this model stage, let us accept first we have to fix our unit again, millimeter by Newton, and let us accept the default mesh. Let us generate the mesh. So we accept just the default sizing. So in this tree as the static structure, we have to, since it's a cantilever beam, we have to put a fixed support at one end. So let us select this face. So this fixed as this face, and let us apply a force at this face. So this is the geometry, and let us select the component and minus 500 Newton in the y direction. So what the solution stage, we ask to calculate the total deformation and the directional deformation along the X, Y, and Z direction. The directional deformation in the X, Y, Z direction. So let us make it the Y axis and Z axis. Let us solve it. Once the solution is done, we can we can see all the results. For example, if you want to see the total deformation, and if you animate this, the total deformation will be maximum at the free end. So the maximum magnitude is 3.06 millimeter, and the minimum deflection is 0 at the fixed end. And if you want to the directional deformation in the x direction, it will be like this. And if you similarly, if you see the directional deformation in the y direction, it will be like this. And similarly, if you want to see the directional deformation in the z direction, it will be like this. So to conclude this video, static analysis is used to analyze when the structure is subject to static load. So by the way, it's introductory. So in the next video, I will show you by making some constraints like sizing and also some other geometry. So I will bring you another tutorial for this today's video. Thanks for watching. Thanks. If you have any doubts relating with this video, you can put your question in the comment box. Thanks for watching. Thanks.